Hey, so in this lecture I want to discuss the coding standards for developing in Unreal Engine. So what is a coding standard? A coding standard is a guide for producing code that is clearly readable and consistent. So it has to be clear, it has to be readable, and it has to be consistent. And this allows engineers to interpret the code quickly. Different frameworks may have slightly different coding standards such as Unreal Engine, CryEngine, and Qt. We should always refer to the relevant documentation for that particular framework or toolset, so that we can understand and adhere to the coding standard for that particular framework. Now, I would like to emphasize that we need to differentiate between the provided libraries or code and the code that you write yourself or inject, that is project-specific code, and all team members must know and adhere to the standards for the framework and also to the standards for the project code, because different companies may have different standards for the project code, in a similar way that different companies may have different coding standards for the frameworks that they produce, such as CryEngine, Unreal Engine, and Qt, for example. So all team members must understand and adhere to the coding standard of both the framework and also the project-specific code. For example, the Unreal Engine is open source. You can write project-specific code for your game, for example, but you can also access and modify or maybe add to the engine code, because again, that is open source. So when writing project-specific code, it is acceptable to have minor exceptions to that coding standard, if it makes sense to do so. But when writing code for the Unreal Engine, then we must always adhere to the EPIC coding standards. For this lecture, we'll step you through the Unreal Engine documentation, the coding standards for developing in Unreal Engine. Always remember that you have these hot links in the Unreal Engine documentation to the right here. If you want a quick link to a specific section, since some of these pages can cover a lot of information. Our goal should always be to write maintainable code, and we can do this by adhering to established standards and best practices. This page outlines the code conventions for developing an Unreal Engine. These are important for a number of reasons. 80% of the lifetime cost of a piece of software goes to maintenance, and hardly any software is maintained for its whole life by the original author. So if someone else comes along and reads your code, it's important that that reader or programmer understands what is going on, not just what you are doing based on their knowledge on C++ and the Unreal Engine framework, but also why you are doing that. You have to comment things properly, and your code should also be self-documenting as much as possible. Adhering to the conventions will improve the readability of the software, allowing engineers to understand new code more quickly and thoroughly. With that in mind, let's start with the class organization. Classes should be organized with the reader in mind rather than the writer. And since most readers will be using the public interface of the class to understand what is going on, that should be declared first, and I prefer to have protected following that, and then followed by the class's private implementation. We also have this copyright notice. Any source file provided by EPIC for distribution must contain a copyright notice, as you can see in this example here. We want to leave the copyright notice for the EPIC files as is, so we want to leave those alone. But for our project-specific code, instead of using the minimal copyright notice that we get by default, such as in your header file, since this is where the programmer will go first to get an overview of what is going on in the class, we can write this sort of header which includes the copyright notice, but that also includes the maintainer, so who is maintaining this code. We need to think about who we can contact for queries about the file, and we can include an overview of what the code file is for. This again is just a silly example. Your organization will decide on what the formatting is and how much detail you really want to have go into each file, but this is just an example. Then the section on the naming conventions is important as well, especially if you have different conventions. In error module C++ 101 and 102, there will be some different naming conventions that is based on my preferences and how I study C++, and also how you may find that in other courses, books and so forth, but of course we have to stick to the Unreal Engine conventions here. So the first letter of each word in a name, such as the name of a variable, is capitalized, and there are usually no underscores between words. Basically, we will be using Pascal case and we will not be using underscores. Then, as we've seen, type names are prefixed by additional uppercase letters to distinguish them from variable names. We've already seen that with the U object and with the A actor. Classes that inherit from U object are prefixed by a U, and then classes that inherit from A actor are prefixed by an A. Enumerations are prefixed by an E. Boolean variables must be prefixed by a lowercase b, so for example, b pending destruction, b has faded, and so forth. Most other classes are prefixed by an F. We will see that with f vector, for example. Instead of using vector, we will be using f vector. That is because the vector is basically a container of floats. That has been an Unreal convention for quite some time. The Unreal header tool will require the correct prefixes in most cases, so it's important to provide those. And as we've seen, when we create a class, that wizard will add the appropriate prefix. So when we create an actor, it will add the A. We don't have to add that ourselves. Same with the U object, that will add a U. Type and variable names are nouns, and then method names are verbs that describe the method's effect, or describe the return value of a method that has no effect. Then of course, variable, method, and class names should be clear, unambiguous, and descriptive. You should avoid over abbreviations. People want to make their identifiers as short as possible. I don't really agree with that. I don't see why you would want to do that, especially for parameter names and so forth. Make it clear for the programmer what the member functions are expecting. Variables will be declared one at a time so that a comment on the meaning of the variable can be provided. We're not really concerned with the Java docs style. You can use multi-line or single-line comments before a variable. Functions that return a bool should ask a true or false question such as is visible, should it do something, and so forth. It is encouraged that you prefix function parameter names without if they are passed by reference, and the function is expected to write to that value. Again, as I mentioned, you want to make it clear to the programmer what the arguments are, what that function is expecting, but also what it will return if it will write to those arguments. If an in or out parameter is also a boolean, then put the b before the in-out prefix, such as bout result. And then of course functions that return a value should describe the return value, which is especially important for boolean values. For project code, I prefer to use camel case, that is starting with lowercase, so not Pascal case, for function formal parameters, because as I mentioned, the documentation basically states that we should use Pascal case for our variable names, but for function formal parameters it makes sense to either prefix those with a lowercase p, as you do with kind of similar to what you would do with a boolean, so lowercase p for a boolean. If that does not work for you, then you can use camel case instead of Pascal case, because those different cases will remove ambiguity, and it makes it easier to identify class members, so member variables for example, and to distinguish those from parameters. You might think that you are setting a member variable, but instead you are modifying a local variable or a formal parameter. So those different cases, again Pascal case for your member variables and functions, and then using camel case for your formal parameters, will help avoid identifier name clashes. And of course, in this way you can have a local variable, so a variable that is local to a function, whether that is a formal parameter or some other local variable, and that can then have the same name as a member variable without having any sort of clashes, because the local identifier will start with a lowercase, but the member variable will start with an uppercase. That again is camel case versus Pascal case, right? So that is also something that you can consider for your project-specific code. The size of int and unsigned int types may vary across platforms, and of course we want to write portable C++ code, so we have these types here that we will be using in Unreal Engine, bool, tchar. For integers we'll be using int 8 for example, int 16, int 32 and int 64, and we'll also have the unsigned int variants of that. We can use the fundamental float and double types, so you may want to take a note on these types. We will not be using the regular int or unsigned int when developing in Unreal Engine. We'll be using these other types, that is for portability. Unreal has avoided the direct usage of C and C++ standard libraries for various reasons, but there are some exceptions to those. So for example, in CMath, all the floating point functions are usable. Some notes here on comments, you should be familiar with these in any case from basic C++ programming. We need to consider all of these points. We need to write self-documenting code. We need to write useful comments. We need to rewrite bad code instead of commenting it. And the comment should not contradict the code. Your code should be clear and self-documenting, and you should only use comments to expand upon already readable and understandable code. That is where it would benefit the reader. From the programmer's programming knowledge and their knowledge on the Unreal Engine, they should establish what is going on, simply from reading the code, because again it needs to be self-documenting, but the how and the why should be explained in comments. We are not explaining what we are doing, we are explaining how and why. We should also strive to keep comments brief, using one-liners instead of using multiple lines to explain something. If you need to provide more comments, then do that in the source file, where you actually go and do the definition, that is the implementation. We should strive to keep our code const correct, Member functions that do not modify their objects should be declared as const. There are some examples on const correctness within this documentation if you need that, maybe as a refresher. We will not be using JavaDoc, and we are not concerned with that since we are not building documentation, but you can read up on this here if you are interested. Some sections here on modern C++ language syntax that you can read through as well. For example, the Unreal Engine requires a minimum language version of C++ 17. And we will avoid using compiler-specific language features. Of course, we should always use null pointer instead of the null macro. The usage of auto is discouraged in Unreal Engine. We need to be explicit with the types, but there are some exceptions to that. It's really useful for type deduction, especially with complex types, since we don't have to type out the same thing over and over again. Again, especially with a long complex type. Some notes on lambdas and anonymous functions. Lambdas can be used freely, but do pay attention to the guidelines here, as outlined within the documentation. On enumerations, we will use the strongly typed enum classes. Also notice that we use the uenum macro before the enumeration. We can use default member initializers to initialize the defaults of a class. This here is a popular choice because the programmer will typically inspect the header file first, that is where the class definition is, before going to the implementation. Now I prefer to keep everything in one place in the constructor. There are some comments on code formatting, such as with the braces for example. Always include braces in single statement blocks. You can see some examples here with if and if else. I prefer this style in any way, so I don't have a problem with this. Some standards for indenting these also go back to the basics of C++. Indent your code by execution block, and use tabs not spaces for white space at the beginning of a line. Also some good advice in the switch statement section. Except for empty cases, switch case statements should explicitly label that a case is going to fall through to the next case. So either include a break or include a falls through comment. We don't really use namespaces all that much in Unreal because the Unreal Header tool does not support namespaces, so they should not be used when defining uClasses or uStocks, for example. With regards to encapsulation, use your best judgment. Fields are only intended to be usable by derived classes, so we provide protected accesses. We can also use the final keyword if the class is not designed to be derived from, and of course the same goes with member functions that we don't want to have be overridable. Also some general style issues that we will become more familiar with as we go along. So for example, we will use the text macro to surround string literals. Don't worry about remembering everything here. Again, this is just an overview, and to inform you of this documentation, this is a handy reference. This section of the documentation includes some examples on these code issues, such as this one down here. We need to make the intent more obvious by avoiding the usage of anonymous literals in function calls. And with that, we're going to wrap up this lecture on the coding standards for Unreal Engine. There were quite a few topics here that I wanted to step you through, but don't worry about remembering everything. You can always come back to the documentation. As you become more familiar and more experienced developing in the Unreal Engine, many of these conventions will stick with you, and you may only have to refer to the documentation periodically. Alright, so that is going to wrap things up for now. I'll see you in the next lecture.